Lastly, part C, complex fractions. I like to call complex fractions the Big Bertha of them all, okay? It combines all your skills and kind of gives you a little more oomph to your math powers, okay? So, steps that we're going to follow. First, we're going to simplify the numerator down to one single fraction. Then we're going to simplify the denominator down to one single fraction. Then we're going to divide the rational expression. So keep, change, flip. Then we're going to simplify, which means eliminate if possible. And then 5, state any restrictions on the variables, okay? So here is our first complex fraction. So step 1 says for us to simplify the numerator. Here's my numerator, 1 over x plus 3. So simplifying my numerator in step 1, I have 1 over x plus 3 over 1. Okay, I'm going to show you guys a little shortcut, especially when you have small denominators. I like to call this chopsticks in a bowl. How this works is that you're going to do a little bit of cross multiplication. So we're going to cross multiply, which is 1 times 1, gives us, so 1 times 1. We're going to grab our rice, and in this case, our rice is a plus sign. We're going to grab our other chopstick to eat our rice with, and that's going to be 3 times x. And then we're going to put it all in a bowl, and that's going to be x times 1. So our numerator becomes 1 plus 3x over x. So that's our numerator. Now, if it was something big, like in part B, then we would do what we did in part B. But seeing how these are smaller numbers, it kind of leads itself to doing a little less work, right? All right, so we now know that our numerator can be written as 3x plus 1 over x. All right, step 2 says we're going to simplify our denominator. So simplify, which means we're going to make it into one fraction. So we have 5 over y plus 4 over 1. And again, we're going to do a little chopsticks in a bowl. 5 times 1 is 5. We have some positive rice here. Other chopstick, 4 times y. Y times 4 is 4y. Divided by our bowl, which is 1 times y is y. And so that would be our denominator. So our denominator is 5 plus, let me write that mathematically proper. We have 4y plus 5 over y. And that is step 2. We now have one fraction in the numerator and one fraction in the denominator. Okay? Step 3 says to divide the rational expression. So we're going to keep, change, flip. So we keep the numerator, 3x plus 1 over x. We're going to change from division to multiplication. And we're going to flip our denominator. So that becomes y over 4y plus 5. We eliminate if we can. Step 3 is done. Step 4, there's nothing for us to eliminate. And so we're going to just finish up step 4, combine. So we have 3x plus 1. And that's y over x times 4y plus 5. And then we're going to state our restrictions. Restrictions would be x cannot equal 0 and y cannot equal -5/4. Remember, if you're wondering, why is that? So for 4y plus 5 equal to 0, I have to subtract the 5. Leaves me with 4y equals negative 5. I have to divide the 4. And that leaves me with negative 5/4. All right, complex fraction. Let's try another. Okay, so again, we want to write our numerator and denominator as single fractions. So step 1 is the numerator. Well, numerator is easy. Numerator is a single fraction is just 3 over 1. Okay, denominator, not so easy, but easy enough. Denominator as a single fraction. So we have 5 over x plus y over 1. We're going to chopstick it. So 5 times 1 is 5. We're eating some positive rice. X times y is xy. And x times 1 is x. So there's my single denominator fraction. So this becomes, sorry, I forgot the negative there. So we have negative 3 over 1 divided by xy plus 5 over x. And we're going to keep, change, flip. So that's what step 3 is all about. Keep, change, flip. So that gives us negative 3 over 1 times x over xy plus 5. And we end up with negative 3x over xy plus 5. All right. Okay, so we end up with negative 3x over xy plus 5. Now, the denominator here is a little different because we have two variables in the denominator that are not being multiplied together, right? And so what's going to happen here is that we're going to still set it equal to 0. So we have x times y plus 5 equals 0. I'm going to subtract 5, and we have xy equals negative 5. Okay, we're just going to define it based on one term. So let's just say we'll do it as y. So I'm going to divide by x. So what we're telling ourselves here is this is true. However, y cannot equal negative 5 divided by x. Or I could have written it as x cannot equal negative 5 divided by y. But we're used to solving for y. So that will be our variable restriction. All right. Now just making sure you understand the process of a complex fraction. So step 1 is you want to make sure your numerator is a single fraction, and it is. Step 2, you want to make sure that your denominator is a single fraction, and it is. Good. Step 3, we're going to apply keep, change, flip. So for step 3, we're using keep, change, flip. So we keep our numerator, we change from division to multiplication, and we flip our denominator expression. So x minus 1 over 3. Okay, then we are going to go ahead and multiply. So we're on simplify, which is what we're going to multiply. So we end up with 4 times x minus 1 over 3 times x plus 2. And there's nothing for us to eliminate, so we've simplified as much as we can. Step 5 is to state our restriction. So our restriction is what would make our denominator equal to 0, which would be x cannot equal negative 2. So our answer is 4 times x minus 1 divided by 3 times x plus 2, but x cannot equal negative 2. And that concludes 11.5, part C.